Hey guys, this is Mr. Gucci here to present the 9.2 notes to you, which is mole conversions. Okay? Now, what am I talking about when I'm talking about mole conversions? I'm talking about a classic problem that occurs in chemistry, which is when we do calculations for quantities in chemical reactions, like for example, when we balance an equation, we are balancing the number of particles in the reaction. You know, how many carbon atoms there are, how many oxygen atoms there are, how many water molecules there are. Okay? We do all of our chemical calculation in terms of number of particles, because it's the particles, the individual particles themselves that are interacting. But we can't count out numbers of particles in a scientific laboratory, even the most high-end scientific laboratory, because these particles are so small. You have a recipe that calls for 2 hydrogen atoms and 1 oxygen atom to make water. Well, good luck counting out those individual atoms. They are infinitesimally small. All right? Infinitesimally small. Yeah, okay? So the problem is we need to find a way to convert a number of particles that we cannot count into an actual mass of particles that we can measure on a scale, and vice versa. If someone tells me, oh, I've got 50 grams here, I've got 63 and a half grams of copper atoms here, well, great, you can measure this, but I can't do any calculations for reacting copper in grams. I have to convert this number of grams into a real number of particles, a number of particles that are interacting. I need to know not how many grams of copper I have, but how many atoms of copper. Not how many grams of sulfur I have, but how many atoms of sulfur. Not how many grams of water, but how many molecules of water. And so we have to do conversions. We have to be able to convert a mass of something in grams into its number of particles, which we measure in moles. A mole is just a number, about 602 sextillion, okay? Later, we're going to work on converting volume of gas into moles. Like, oh, I have 67 liters of gas. How many moles of that? And so forth, okay? So, let's say you had, oh, I don't know. Well, let's take this copper here that I got. Okay, so I have got myself some copper. Okay, now let's say I have got 150 grams of copper. Okay, great. 150 grams of copper. I was able to measure that out in the lab, but I can't do any calculations until I figure out how many copper atoms that is, i.e., how many moles of copper. Remember, a mole is just a number, like a dozen is 12, or pi is 3.14159. A mole is just a number. All right, that number happens to be 602 sextillion, but it's just a number. So I need to convert these grams of copper into a number of particles. Now to do that, I'm going to have to do some conversion here. All right? I have to get out of grams, so grams needs to go on the bottom here, remember dimensional analysis, and I need to convert into moles. I have to get out of a unit of grams of copper into a unit of moles of copper in order to move forward with my chemical calculations. Well, how do I do this? How do I figure out what's the relationship between grams of copper and moles of copper? Well, I'm talking about grams and moles. This might sound familiar. This is just the number that you find on the periodic table. All right? It's the molar mass. Copper has a molar mass of 63.546 or 63.55 grams per mole. Copper has a molar mass of 63 point, double check that because I have no memory, 55 grams for every mole. All right, that means for every 1 mole of copper, for every 602 sextillion copper atoms I get, it weighs 63.55 grams. 63.55 grams is 1 mole of copper. 1 mole of copper is 63.55 grams. So when it comes time to plug the numbers in here, 63.55 grams, well, 63.55 is going to be on the bottom because grams is on the bottom. And that's 1 mole of copper. And this is how you can get out of grams into moles. To go from grams to moles, you just divide by the molar mass. All right, let me reiterate that for you. Okay, to convert from grams to moles, you are going to divide by the molar mass. Okay, to go from grams to moles, you're going to divide by the molar mass. Well, let's see how many moles of copper this is. All right, 150 divided by 63.55. 150 divided by 63.55. I get this is 2.36 moles of copper. This is 2.36 moles of copper, or 2.36 602 sextillions of copper. It's 602 sextillion copper atoms times 2.36. Just like a dozen is 12. If I had 2.36 dozen, then it would be 2.36 times 12. But this is 2.36 moles of copper. This is how many copper atoms that I have. So when you're going from grams into moles, when you're converting from a mass of a particle into how many there are, from grams into moles, you divide by the molar mass. Now, let's say this copper was going to be used in a chemical reaction. I will use the most simple chemical reaction, okay? Copper plus sulfur yields copper 2 sulfide. This is real easy because this balances to 1 of each, all right? So, copper plus sulfur yields copper 2 sulfide. Simple chemical reaction, everything just balances out to 1, okay? Now, this chemical reaction, again, is a chemical reaction balanced in terms of number of particles. So I can't use mass in here. I can only use number of particles. Now let's say that I have 2.36 moles of copper. All right, 2.36 moles of copper. If I wanted to completely react it with the sulfur, well, I would need 1 to 1. I would need the exact same amount of sulfur. I would need 2.36 moles of sulfur because they react in a 1 to 1 ratio. Okay, so now I know I need 2.36 moles of sulfur, but that's a number of sulfur particles, and there's no way I can count that out in a laboratory. What I have to do is I have to figure out, okay, if I have 2.36 moles of sulfur that I want to react with this copper, I have to figure out in real world quantities how many grams of sulfur is that? How many grams do I need to go and weigh out on a scale? Okay? So to do this, I need to do, once again, a conversion. I have to get out of moles of sulfur. All right, moles is on top, so I got to cancel it out on the bottom. I have to get out of moles of sulfur and convert it into grams. It's a sloppy G. Into grams of sulfur. I have to get out of moles, so moles opposite side, and into grams. Now, once again, I got to put some numbers here. I got to put some numbers here so I can do some math with them. And once again, we can look to the periodic table. To find the relationship between grams and moles for sulfur, I just go to the periodic table here. Sulfur has a molar mass of 32.06 grams per mole. Sulfur, 32.06 grams for every mole. Each mole weighs 32.06 grams. If I had 1 mole of sulfur atoms, 602 sextillion sulfur atoms, it would weigh 32.06 grams. 32.06 grams is 1 mole. So what numbers go where? Well, 32.06 grams, 32.06 goes on top because grams is on top. And because that's the weight of 1 mole goes on the bottom. So we cancel out the moles, and what we're doing here is we take the moles and we multiply it by that molar mass. To go from moles into grams, we multiply by the molar mass. Or as a student of mine from a previous year, Siani, said, Mr. Gucci, if you start with moles, you multiply. All right? If you start with moles, you are going to multiply. So, again, what I've done here is I've set up some dimensional analysis here to show you that when you're going out of grams into moles, when you're going from grams to moles, you divide by the molar mass. And when you go from moles into grams, you multiply by the molar mass. Let's do this, by the way. 2.36 times 2.36 times 32.06. What did I get? 75.7. And again, let's just pause and appreciate the significance of this. What we've done with some simple calculations is we've figured out that if we're starting with 150 grams of copper, if we are starting with 150 grams of copper, then by converting that into a number of copper atoms and comparing it to what number of sulfur atoms we need, we can figure out what mass of sulfur we need. So we've gone from a real-world measurable amount of copper, and we figured out what real-world measurable amount of sulfur we need. This is, in essence, chemistry. All chemistry is essentially this. You know what real-world amount of a substance you need. Say, for example, you need 1 million grams of COVID-19 vaccine. Well, you know how many grams of COVID-19 vaccine. You can figure out how many particles of COVID-19 vaccine that is. All right? What number of COVID vaccine particles do we need? And working backwards, if you know how many particles you need to produce, you can work backwards and figure out, well, how many particles of ingredients do I need? What substances do I need to put into this bioreactor, this chemical mixer to make this COVID vaccine? All right? And then once you figure out how many particles of the ingredients you need, you can figure out real-world measurable amounts. This is, in essence, all of chemistry. All chemistry is really just variations on this theme. I need to produce this amount of real-world substance, so I got to figure out how many particles it is, figure out how many particles of reactants I need, and then from that, figure out, okay, well, then this is how much real-world weight of reactants I need. That is chemistry. This is chemistry. What we're doing right now, that's chemistry. Okay? So to help you out with this, if you're converting from moles into mass, like you would need to do if you need to figure out, okay, I have this many moles I need. What real mass should it be? All right? If you're going from moles into mass, you multiply. Going from moles into grams, you multiply. If you're starting with a mass and you have to figure out how many particles it is, if you're going from mass into number of particles in moles, you divide. If you're going from moles to mass, you multiply by the molar mass. If you're going from mass into moles, you divide by the molar mass. And that is, in essence, the majority of what chemistry is. All right? Good luck, guys. The next video will be a homework video.